Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem. Form the partial differential equation by eliminating the arbitrary constants from z equal to 1 by 2 times square root of x plus a plus square root of y minus a plus b. We are given an equation or a relation z equal to 1 by 2 into square root of x plus a plus square root of y minus a plus b. Consider as equation number 1. Now we are asked to find or form a partial differential equation by eliminating the arbitrary constants a and b, right? So in order to find arbitrary constants, in order to eliminate, we'll just partially differentiate one with respect to x and y. First we'll begin with partially differentiating one with respect to x. Okay, we'll see the detailed process and later we'll go for the shortcut. Right, now apply dou by dou x on both sides of 1. Since we are partially differentiating with respect to x, so we'll treat y as constant here. Right, this gives us dou z by dou x equal to constant 1 by 2 into dou by dou x of first term plus dou by dou x of second term plus dou by dou x of third term. Okay, since we have a notation dou z by dou x equal to p, just replace dou by dou x by p. You'll get p equal to 1 by 2 into partial derivative of square root of x plus a with respect to x is 1 by 2 root x plus a into inner derivative dou by dou x of x plus a plus partial derivative of a constant. Since we are partially differentiating with respect to x, so y will be treated as constant, right? So here y minus a is treated as constant, total this term is treated as constant. So the partial derivative of a constant with respect to x will be 0 plus partial derivative of a constant with respect to x 0, which gives us p equal to 1 by 2 into 1 by 2 root x plus a into partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x is 0. Okay, which gives us p equal to 1 by 4 into square root of x plus a. Okay, now bring this 4 to LHS, you'll get 4p equal to 1 by square root of x plus a, or we can write it as square root of x plus a equal to 1 by 4p. Or we can write this as square root of x plus a equal to 1 by 4p. Consider as equation number 2. We got square root of x plus a equal to 1 by 4p, right? Now partially differentiate one with respect to y. Just apply dou by dou y on both sides of 1. Which gives us dou z by dou y equal to constant 1 by 2 into dou by dou y of first term. Since we are partially differentiating with respect to y, so we'll treat x as constant here. Dou by dou y of second term plus dou by dou y of last term. Uses, since we have a notation dou z by dou y equal to q, so we'll replace LHS part by q. You'll get q equal to 1 by 2 into partial derivative of constant with respect to y is 0 plus partial derivative of square root of y minus a with respect to y is 1 by 2 root y minus a into inner derivative dou by dou y of y minus a plus partial derivative of a constant with respect to y 0, which gives us q equal to 1 by 2 into 1 by 2 root of y minus a into partial derivative of y with respect to y is 1 minus partial derivative of a constant with respect to y is 0, which gives us q equal to 1 by 2 2s are 4 into square root of y minus a, or we can write it as 4q equal to 1 by square root of y minus a. Just bring this 4 to LHS, you'll get 4q equal to 1 by square root of y minus a, or we can write it as square root of y minus a equal to 1 by 4q. Square root of y minus a equal to 1 by 4q. Consider as equation number 3. Now observe 1, 2 and 3. See, we can replace from 2, we can just replace square root of x plus a by 1 by 4p, and you can replace square root of y minus a using 3. Okay, but by replacing these two using 2 and 3, a gets eliminated but b remains the same, right? So this won't work. Now we'll observe 2 and 3, right? In 2 you are having square root of x plus a equal to 1 by 4p. In 3 you are having square root of y minus a equal to 1 by 4p. So you can get value of a from 2 and value of a from 3 also. So let's see that. Squaring on both sides. Gives us, right? From this we'll get, just take this x to RHS, we'll get a equal to 1 by 16 p square minus x from 3 we have square root of y minus a equal to 1 by 4q. Just by squaring on both sides you'll get right, which gives us y minus a equal to 1 by 16q square. Now bring this term to LHS, take this a to RHS, you'll get y minus 1 by 16q square equal to a, right? So you are having a equal to 1 by 16 p square minus x and a equal to y minus 1 by 16 q square, or better I'll write this as a equal to y minus 1 by 16 q square, right? So you have a equal to this and a equal to this. So from these two we can just equate these two, right? Consider as equation number 4, this as equation number 5. So from 4 and 5, okay, here you are having square root of x plus a whole square, right? Since we know that square root of a can be written as a power 1 by 2, so we can write square root of x plus a as x plus a power 1 by 2 whole square, and also we know that a power m whole power n can be written as a power m into n. Then we can write it as x plus a power 1 by 2 into 2, where 2 gets cancelled, you'll get x plus a. That is what we have written here. Likewise, just replace or You can just find square root of y minus a whole square. You'll get the same thing, x minus a. Okay, I mean this is for x plus a, and you'll get the same, you'll get y minus a for square root of y minus a whole square by using this process, fine. Well, now coming to 4 and 5. From 4 and 5, we get 1 by 16 p square minus x equal to y minus 1 by 16 q square. Just simplify it. Bring this term to LHS and take this x to RHS. You'll get 1 by 16 p square plus 1 by 16 q square equal to y plus x, or we can write this as 1 by 16 into, just take 1 by 16 common from these two terms, you'll get 1 by 16 times p square, 1 by p square plus 1 by q square equal to x plus y. Okay. Then 1 by 16 into, take the LCM of these two, you'll get p square into q square. In the numerator, you'll get q square plus p square equal to x plus y, right? We can write this as p square plus q square by 16 p square q square equal to x plus y, right? Now take this term to RHS, you'll get p square plus q square equal to 16 p square q square into x plus y. See, it does not involve any arbitrary constants, right? It is a required partial differential equation. Now let's see the shortcut. Partially differentiating one with respect to x, dou z by dou x equal to 1 by 2 into partial derivative of square root of x plus a is 1 by 2 root x plus a into inner derivative. Partial derivative of x with respect to x is 1 plus partial derivative of a constant with respect to x is 0 plus partial derivative of a constant with respect to x is 0 plus partial derivative of a constant with respect to x is 0. Since dou z by dou x equal to p, you'll get p equal to 1 by 2 2s are 4 root x plus a, or we can write this as square root of x plus a equal to 1 by 4p, which we have considered as equation 2. Now partially differentiate 1 with respect to y. Dou z by dou y equal to 1 by 2 into partial derivative of a constant with respect to y is 0 plus partial derivative of square root of y minus a with respect to y is 1 by 2 into square root of y minus a into partial derivative of y with respect to y is 1 minus partial derivative of a constant with respect to y is 0 plus partial derivative of a constant with respect to y is 0, which gives us, since partial derivative of y with respect to y is q, use the notation q equal to 1 by 2, 2 2s are 4, right? You'll get 1 by 4 into square root of y minus a. From this you'll get square root of y minus a equal to 1 by 4q, which we have considered as equation 3, right? Now by observing 1, 2 and 3, simply by substituting 2 and 3, the arbitrary constants won't get eliminated. So what we'll do is we'll just pick a from 2 and 3. We'll just find the value of a from 2 and also from 3. Okay, from 2 you have, by squaring on both sides, you'll get x plus a equal to 1 by 16 p square. Now, take this x to RHS, you'll get a equal to 1 by 16 p square minus x. And from 3, you have square root of y minus a equal to 1 by 4q. By squaring on both sides, you'll get y minus a equal to 1 by 16q square. Now, bring this term to LHS. Yeah. And take this a to RHS, you'll get y minus 1 by 16q square equal to a. See, from these two, you have a equal to one term, a equal to one term. So just equate these two, you'll get, consider as 4 and 5. From 4 and 5 you'll get 1 by 16 p square minus x equal to y minus 1 by 16 q square. Just bring this term to LHS and take this x to RHS. You'll get 1 by 16 p square plus 1 by 16 q square equal to x plus y, right? Take 1 by 16 common, you'll get 1 by p square plus 1 by q square equal to x plus y. Or just simplify it. You'll get 1 by 16 into q square plus p square by p square q square equal to x plus y, which gives us p square plus q square by 12, sorry, it's 16, right? 16 p square q square equal to x plus y. Now take this term to RHS, we'll get p square plus q square equal to 16 p square q square into x plus y, which is the required partial differential equation. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.